Good day, everyone. Welcome to MS Tutorial. And this time around, the topic we'll be checking is an aspect of calculus. Okay, and yeah, we'll be doing something on limiting value of a function. As you all know, that a function is an expression or an equation which is usually defined by y. What do I mean? If I have y equals to x squared plus x plus 2, this is a function, okay, and y is defined by this function. Also, it can also be written in the form of f of x equals x squared plus x plus 2. So the 2 still implies that it is a function. So in this aspect of our calculus, which I term calculus 1.0, that is part 1.0, limiting of function, okay, we'll try to check how to limit different type of words of function. So let us get into that. Alright, this question says that we should try to limit x to 0 in this function, and here we have 6 minus 3x plus 5x squared minus 2x raised to power 3. So let us see how to limit that. What do we do here? So here I want to try to write it as an individual expression. So what am I going to have if I write this as individual expression? So the moment I write it out as an individual expression, what do I have here? I have 6. So this becomes x equals to x to 0, 6. Here I have minus 3x. Then we are limiting x to 0, and here plus 5x squared, then x to 0 minus x to 0 into x raised to power 3. So what's the next thing we need to do? As you all know that the elements which you are trying to limit is what is x. So which means all other coefficients can come before each of the expression x squared, x raised to power 3, x, and this. So let us check that out. And in this situation also, now if I limit the whole of this, where we have x is limit to 0 here, to 0. In this case, I'm having 6 here. What this one implies is that there is no x here, okay? So 6 will definitely remain. While in this case, I can limit x to 0 in the whole of the expression. So let us see what we're going to have next. Now, from the idea of indices, here, if I have x raised to power 0 here, this x raised to power 0, x raised to power 0 here is definitely equals to 1. And if you multiply 6 times 1 here, I'm still going to have what? 6. So here, let's try to, limit x to 0. So from here, I can write this as 6 lim s to 0 with 1. Why in this case here, the moment I limit x to 0, what am I going to have? This become 3, then x become what? 0 here, plus in this case here we have 5, here x becomes 0, here so I have minus 2, where that becomes what? 0, and what do I have there? This one is out, this is out, this is out, but in this case here, it will mean it's going to have 1 back. So since x is not present here, so the answer we're going to have here will then be 6 plus 0 plus 0 plus 0. So answer will be 6. Let us check another example very quickly. So let's check this other example, which says, so this other question says that we should limit x to 1 in this case here. So how do we limit x to 1 in this case? Okay, let's check it out. So as first, I want to try to write everything as individual expression. And what do I mean by that? I'm taking the individual expression of all the denominator. Then after taking the individual expression, I'll come down to the numerator as well and take the individual expression. So let us see how to do that. So looking at it from here, this is what we have here now. This one becomes x squared from x squared plus 4x minus 9, then 2x squared minus x plus lim 1. So since we are limiting x to 1, so what are we going to have next? Okay, that means that in this case now, whenever we see x, you substitute what? 1. Okay, substitute 1 wherever we see x. So what this one change to here? Okay, let's see what we have here. Yeah, I'm having lim x squared. So this remains lim x squared. But this is lim 4x here. So I draw 4 back to this point here, having lim x, then here lim 9 remains. Why lim 2x squared become what? 2 lim x squared, which is the same thing. Then here, since x does not have any coefficients here, so I limit as lim x. What the last one will give us what? Lim 9. So very quickly, let us now substitute 1 for wherever we see x. So in this case, this become lim. This become 1. Okay, that become 1 square plus 4 in bracket 1. Then we all know that 9 will remain since there is no x here. All over here, this will become 2 into bracket. We are limiting x to 1 here. So that become 1 square. So you limit x square, that become 1 square minus this one is only 1 that will remain here. Okay. That will be 1. Then in this case, since there is no x here, 1 will remain. So we have plus 1 here. So what will be our final answer from here? What will be our final answer from here? 1 square gives us 1. Plus 4 times 1 will be 4. Then here you have minus 9. All over this will be 2. 1 square will be 1, 2 times 1 that will be 2. This will be minus 1 plus 1. So finally, what do we have as our answer? This will be 5 minus 9 all over minus 1 plus 1, that's obviously 0. So here we have 2 down here. Then finally, what do we have as our answer here? 5 minus 9 will give us minus 4 all over 2. So having minus 4 over 2 then, our final answer from this question, so minus 4 over 2 from the question here, minus 4 over 2 will give us minus 2. So that's the answer to this particular question. Example 3 from this question. Now it says we should limit x to 2 in the expression x squared minus 9x over x plus 3. Now many of you may want to substitute directly in this type of question, but substituting directly is very erroneous. So instead, what do? The expression we have at the numerator there, do you get that now? X squared is one expression, minus 9 is also. Now what do we call this type of expression? Okay, we call it difference of 2 squared. And we all know that when expressing difference of 2 squared for x squared and minus 9, what are we expected to have? So we actually have a video on difference of 2 squared. If you check the lessons we had on quadratic equation, where we deal with expression under difference of 2 squared. So you should be able to find the link in the description below. So let's quickly solve this question very quickly. So the expression what I have here, x squared remains x squared minus 3x squared over x plus 3. So in this case here, we can also write this as x minus 3 with x plus 3. Okay, which means that if you expand what you have up here, you get this particular expression back. If you expand it, you get this expression back. So in this case now, this can take care of this. So what I have there, I have x to 2, okay, with x minus 3. So from there now I can now express them as individual expression, giving us lim x to 2, okay, that is x, then I have minus lim 3, that is x to 2. So in this case, this is what we have. So lim 3 remain. Why in this case, now we have to limit x to 2. So this one become 2, okay, minus, so this is lim 3, there is no x, to remain what? 3. So answer here will be minus 1. So minus 1 is the answer to that. Let's check another example. Alright, let's see this question. It says we have to limit x to infinity. This sign we have here means infinity. So we have to limit x to infinity. Obviously, the moment you see this type of question, okay, you should know that you have to limit x to 0. Yeah. So let's see. In this case here we have 2x raised to the power 3 minus 5x plus x minus 2 all over, and so limit everything else together with x raised to the power 3 plus 4x plus 5. So what are we expected to do in this question? It's very, very simple. Very simple. So now let's check. Looking at this expression, okay, this is not something that we can easily factorize. So all we need to do is that let us try to factor out x, that is x squared, x from the numerator and denominator. So what are we expected to do? So let's check out. Let's check out this. This will mean x to infinity, okay? And the numerator, x cubed. I want to factor out x cubed and x cubed down. So for the numerator now, this is what I have. If I factor out x cubed up here, okay? In this case here, 2x cubed over x cubed. What will remain, okay, is just 2. Okay, so let's come to the second aspect. That's minus 5x squared over x cubed. Here, I'll have minus 5 over x, because 1x will be left down, okay, y up, so in that case I have minus 5 over x. So let's come to this part now. This part, if I have x over x cubed, okay, 1x, 2x will be out here, 1x will be out here, why 1x also be out here, so it means 2x down. So here I have plus 1 over x squared. Then here, obviously we divide 2 over x cubed, we still have what? 2 over x cubed. So here I'll be having, so if I take this now, I'll be having minus 2 over x cubed. So let us close that bracket further. Let's come to the numerator again. Okay. If I take x cubed out, okay, x cubed over x cubed will obviously be what? 1. So here I'll be having 1 for this first expression. The next sign is plus. Come to 4x. If I take 4x and I divide by x cubed, okay, x is out there, I will have what? 4 over x squared. So I'm having 4 over x squared. Then the last but not the least, if I take 5 over x cubed, here it's remaining plus 5 over x cubed. Okay, that's 5 over x cubed. So from here now, we can then continue with our limiting. So let's check from this part now. I can say that here I'll take this and this out. So what we have left here, will now be lim x to infinity. Okay, we have 2 minus 5 over x plus 1 over x squared minus 2 over x cubed, then all over 1 plus 4 over x squared plus 5 over x raised to the power 3. Then when you close the bracket there, that's all of them. So here, without wasting time, you can just try to substitute x equals 0. So what do we have here? this will obviously be 2. For the numerator, okay, we have 2 minus 5 on 0 plus 1 on 0 squared minus 2 over 0. Then all over 1 plus 4 on 0 squared plus 5 on, that's 5 on 0 raised to power 2. So obviously we know this is the out, this is the out, this is the out, this is the out, this is the out. So what we have here, 2 over 1. So the answer will be 2 for this particular question. So let's check this question now. This one says we should limit x to 0 in one term. This expression x squared minus 3x minus 10 all over x squared minus x minus 6. So in this case here, now checking this type of expression, okay, when anytime you give this type, please always check if the expression is factorizable, okay, because there are some expression there that will be factorizable. So try and check. So if it is factorizable, please make sure you factorize it before, expressing the limit of the value. So let's try to factorize what we have here and see what we get. So I will try to factorize the numerator. Okay. Let's factorize the numerator now. In this case here, you notice that this is x squared. Okay. For the product of x squared, this one here. Okay, if I take minus 5 times 2, minus 5 times 2 is equals to what? Minus 10. Why minus 5 plus 2? Okay, will give us what? Because so from here, we can take x squared minus 3x minus 10 to be x squared minus 5x plus 2x minus 10, okay, as an expression. Then from here, factor out x. Okay, so I'm taking this and this first. Let's take this one and this one here. Then later I'll take this and this. So this one becomes x minus 5. Obviously, if I take plus 2 out here, okay, that will be x here minus 5. So if you check this time, this is this time, this 2 times x, then this time this is 0. So from here, we have x plus 2 and x minus 5. This is for the numerator. So let's take the denominator and check it is factorial as well. So for the numerator, we have x squared minus x minus 6. So looking at the product, you multiply this times this, what do you get? You notice what we have to be minus 3 and 2. Okay? So there, we factorize now the one, that becomes x squared minus 3x plus 2x minus 6. Okay? So if we take that, minus 6. So if we take that, we have x, okay, minus 3. That is factor of x. Okay, that will be x minus 3. Okay, then plus 2 is x minus 3. So obviously from here, our answer becomes x plus 2 x minus 3. So this is the factor for the numerator. So we can now input it here to give us x to 0. For the numerator now, we become this as x plus 2 and x minus 5. Why for the denominator, we are going to have x plus 2 and x minus 3. So then, notice that this one can take care of this. So here we have ln x to 0 for the denominator now. We have this, for the numerator we have this, we have x minus 5 up, then x minus 3 down. Okay, so to solve the question further now. So solve the question further now, what do you have here? So I can split this one to ln x to 0 or x minus 5 on in minus 3. Okay. So from here, I can have lim x is what? Lim minus 5, then x to 0, x to 0, all over lim x here, x to 0 minus lim 5, x to 0. So what are they? Okay, so here, in this case, we can have, so this one is 0, that will be 0 here. This does not have x, so here we have minus 5. We have minus 5 here. All over here, limit x to 0, that's 0. Sorry, this is a minus 2. Okay, that's minus 2. So minus 2. So answer become minus 5 over minus 2. So finally, our answer becomes minus 2 to minus 5 over 3. So you can also write as 1 over 2 and 3. So that's the answer to this particular question. Okay, 5 over 3 or 1 over 2 over 3.